physics. Today we're going to talk about potential energy, specifically gravitational potential energy. When we're looking at this, potential energy is stored energy, and because of height and gravitational potential energy, that's where the stored energy comes from. So to start off, I want to use this ramp here to show you something. Both of these are the same height. So if I release one over here, or if I release it over here, they'll both have the same potential energy. Notice the length of this track versus the length of this track. With them being the same height, what you should see is that if I start it on one side, it'll make it all the way up over to the other. So then we're going to transfer this potential energy into kinetic energy by letting it go down. And then when it gets down at the bottom, it's going to have the highest kinetic energy it could possibly have and the lowest potential energy that it will have. And then it's going to come all the way back up to here. So let's see if that works. One thing you should notice, as this is going back and forth, you notice that it gradually loses height. Some of that energy has to go somewhere. We're going to talk about that in class. Okay, so in class, we basically went through and we saw that the object started over here, and it rolled all the way back up to here, and it did not go off the track because the height of these two guys are the same. What we did notice, though, is over time, it gradually started making its way down there. Some of that energy is lost. Now, that would then think to go against the law of conservation of energy, because energy is not created and destroyed in a system. But when the system is this, if it is a closed system, that's the case. If it's an open system, energy can be lost. So the overall energy of the universe is conserved, but the energy of this system, you do lose it. You do lose energy. And so you can notice that as the object slowly makes its way down to the bottom. If I let this guy go over time, we'll start it here just so it doesn't last as long. One thing we'll notice is over time, eventually it will stop. This should be intuitive to you. We know that objects aren't going to go forever like this. Well, there are things being in play. If you remember back to forces, we have friction taking place, as well as if you listen, we hear the sound. So what happens is over time, as this object rolls on the track, this track would get hotter. So that's energy lost to the heat into the track, as well as we can hear it. And so as we hear that sound, energy is lost that way. So this in itself would be an open system because energy is lost from this system. It doesn't keep going on perpetually. But the overall energy in the universe is a closed system, therefore it is conserved. So we treat, when we're talking about conservation of energy, we treat it as if it's a closed system. First, so that you can kind of get the idea, is that the total potential energy up here would be the total kinetic energy down here. So as far as this is concerned, if this was on the ground, now of course this is higher potential energy than here, but this is not a zero because it's not on the ground, it's up on my desk. But what you will find is, over time, this is an open system, not a closed system, and therefore it loses the energy over time.